This is a solution for Jacob's Chapter 11, Problem 16, and we're in the process chapter, and we're trying to understand what these different processes, sub-processes within the overall process, how they relate. There's things like blocking, there's buffering going on here, starvation, bottleneck. These are all these terms. There's throughput rate in here, and we'll take a look at some of these things and analyze the system. Okay, so this is your factory, let's say. Wally's Widget World is your factory. You got to figure this thing out as to how many orders you can process so you make your customers happy. So the first process is taking the order at 100 customers per hour. Your throughput rate is 100 customers per hour. On pick orders, it's 80 customers per hour, and on pack orders, it's only 60 customers per hour. Immediately you can see the bottleneck is going to be the pack orders. If you let each of these processes run full out at their top rate, you can see that the second stage is not going to be able to process the first stage output fast enough. At about 20 customers per hour difference, at the end of the first hour, you're going to have 20 customer orders sitting here in this buffer right here. Okay. Very similarly, using the numbers they have, again, 20. The difference is 20 customers per hour between the second and third stage. You're going to have a cache or a backlog of orders backing up into these two buffers here. Okay. So there's a couple ways to handle that. One of them is just work 12 hours and let the bottleneck determine how many per day you're going to make. You're only going to work toward the slowest part of the process. Or the other thing is, what if you run 12 hours on your fastest process and then give overtime to the downstream events so that they can catch up and finish all those 12 hours worth of order taking? So the first question is, what is the current maximum output of the process, assuming that no one works overtime? The maximum output meaning the maximum number of orders that are put out from this. Okay, so we can do it graphically, and I'll show you over in an Excel file here how that works. So I drew up something here that should help. Okay, so take a look at this. We have on the side here the hours through the day. Here's the first hour, second, third hour, fourth hour, all the way through 12 hours. That's how much we're nominally open, 12 hours a day. And across the top, we have a process up here. Process, I'll put that in here. Process 1, 2, and 3. That's the take process, the pick process, the pack process. So it just matches this diagram over here. Okay, because we're going to run up some numbers in here, and this is one way of taking a look at solving the problem, that first part of the problem there. So you have process 1, 2, and 3. I have the rates here at 100 per hour, 80 per hour, 60 per hour. And I delineated a buffer between each of these two because we need to start seeing what happens. So this is one way to solve the first problem here, the part A of the problem. Okay. So I've covered up some of the data in here. I did it ahead of time to shorten up the video a little bit. But at the end of, we're looking at the end of hour 1 out of process 1. You're going to have 100 orders sitting in, or you will have processed 100 orders. Okay. At the end of the second hour, you'll have processed 200. Okay, so it should be fairly obvious what's going on here. Is that you're just adding 100 every hour. That's the throughput rate and how many hours you work, and you just multiply those two together, and you get the full output rate. And when you do that, okay, nothing fancy there. At the end of 12 hours, the capacity of the first process is 1,200 over 12 hours. Okay, so that's all that's saying there. Okay. Now we know process 1 is working faster at the rate of what? At the rate of 20 per hour faster than stage 2. And stage 2 or process 2 is working at the rate of 20 orders per hour faster than stage 3. So our buffers are going to start building up here. That's what I want to show you here. I'll show you the first line. Okay, after the first hour, all we did was we processed 100 orders up here, take 80 for pick, 60 for pack. But because process 2 is 20 units per hour, or 20 orders per hour slower than stage 1, we have a buffer now of 20 sitting in this buffer at the end of hour 1. Okay, this is processed 80 per hour, but you have an excess of 20 per hour that it couldn't handle. So at the end of an hour, you have 20 orders sitting in there in that buffer. The same thing goes for the buffer that happened between the pick process and the pack process. It's 20 orders difference between pick and pack. So at the end of 1 hour, you're going to have 20 orders sitting in a buffer. So for every hour, we're just showing what happens. After 2 hours, you're going to have You have processed a total of 200 up here, 200 orders up here, and you will have now a buffers building up. What's happening is you have 40 orders sitting in this buffer, 40 in this, and every hour this keeps building up. Okay, keeps building up. Okay, one way to ask this question: what is the current maximum output of the process, assuming that no one wants to work overtime or no one works overtime, is how many can you produce at the bottleneck? The bottleneck is the third process. It does 60 per hour. And at that rate, I'm going to drop this all the way down. If we only look at the third process, of course, at the end of 12 hours, you've built up a buffer of, at the end of 12 hours, you can only process 720 pack processes here, or 720 orders via the pack process, which is the bottleneck. So the slowest part of the system only lets you do 720, whereas the other two stages can run faster. At the end of 12 hours, if you let them run without restricting them, they would have created 1,200 orders, and they would have created 960 orders processed at the pick level. Okay, so that's the difference there. So the answer is, for A, where are we going to limit this thing? To go back to the question, what is the current maximum output of the process, assuming no one works overtime? Well, no one wants to stick around and process these things in the buffer, so this number 720 jumps out of the page saying, look, only produce 720 because that's all the slowest part of the process can handle. Thinking ahead, that also tells us that people working on process 1 can leave earlier because they've gotten way up at this level up here. You're into the area of 720 orders that they can take, and they're done at the 7th or 8th hour here, and they can go home early, so they only have to work 8 hours a day. The pick people get to 720. They produce 720 at the 9th hour. They can go home at the 9th hour. And poor little people that are working for the third process here have to chug along at 60 per hour, and they have to work the full 12-hour shift to get 720 down. Okay, so now you just see how this works. That's how that answers that question. But they're going to flip things around. How long will the picking and packing on B here? How long will the picking and packing operations have to work if we have a day where the order taker works at the maximum capacity? Okay, so that's why we have the full table built out here. Okay. And if we work unrestricted, the people of process 1 can produce 1,200 in that 12-hour shift. This is a little different problem. They're saying, let them work the full 12-hour shift as fast as they can, taking 1,200 orders, and then leave it to process 2 and process 3 people to stick around. They have to work overtime and get rid of these buffers here. Okay? So what happens is at the end of the 12 hours, if process 2 and process 3 continue to work, process 2 at 80 per hour needs to get rid of the 240 that are sitting in the buffer. They have to get rid of the excess here, right? So if they're working at 80 per hour, we're going to put some numbers in here, okay? So after we're going to block in, I'm just going to go through 24 hours here just to have them handy, okay? So this is the main part of the day. I'll colorize that so you can kind of keep your eyes on it. That's good enough. Do something like that. That's the first 12 hours of the day. And then these other process people have to stick around for process 2 and process 3 to get rid of their buffers. And what's going to happen, now process 1 is not producing any more. So there's no new orders are coming in. It just has to get rid of the existing old ones after 12 hours. So after the first hour, it got rid of 80. So 240 minus 80. In fact, I'll put it in there that way. Equals that minus 80. It can process the next hour. Okay. So after the 13th hour, it's now diminishing. See, process 2 is chipping away at the buffered orders that were sitting here. And after the first hour, it got rid of 80. So 240 minus 80 is 160. After the second hour of overtime, they reduced it by another 80. And after the third hour of overtime, they've taken care of all 240 of those orders, and they can go home. That's how that works, okay? And all you have to do is say I just want to complete the column here, is that you're completing 80 every hour, so I'm counting how many they've completed, just to show that at the end of the 15th hour, the second process has gone through all 1,200 orders and can go home now. Okay, but now let's take a look over here. What's going on down at the third process here? The people there haven't seen any relief for 3 hours because the second process is still firing away 80 per hour to the 60 that the third process can handle. So there's still a 20 order per hour difference between the two processes. Okay, so what we can do is we know we're chugging away as fast as we can here. Okay, and for every extra hour, process 3 is going to add another 60. So it's operating at 60 per hour. And really, if you use Excel, all you have to kind of do here is drop this down until that number is 1,200. Oop, that did not work. So through the speed of Excel, what I did is I just kept adding 60 down here until we've processed all the original 1,200. And you can see that it comes across here from the 20th hour. I'll colorize that so you can see it. Okay, so it took all the way through the 20th hour for the third process to finish that. Okay, I'm going to take a break here and start the rest of the solutions in a different video just to break the videos up.